back. It's me, Tinkerbell. We're going to talk about density because fairies are not very dense. There's a pun on those words somewhere. All right, density is mass per volume. So if you have a lot of mass packed into a little bit of volume, you have something that's very dense. And you're going to do a lab with this. So if you take, let's think, a piece of lead, a piece of metal, and you put it into water, it has a really high density. There's a lot of atoms packed in tight. So density is how tight the atoms are packed in together. If you take a piece of styrofoam, styrofoam has air pumped into it, and so it spreads the molecules out. And so it's taking up a lot of space, but there's not a lot of mass, so it has a low density, so it's going to float on water. We often, because we're water-based, the Earth's water-based, they thought it was one of the original elements, so they said, hey, let's compare everything to water. So water has a density, H2O, has a density of pretty much close to 1 gram per milliliter. Turns out density is temperature dependent. That's actually only at 4 degrees. As they got to be able to use more and more sig figs, it turns out like at room temperature, it's 0.998736, which is great. That's pretty dang close to 1. So we're just going to go with 1. If something is less dense than water, it will float on water, and its number will be less than 1. So styrofoam, fairy dust. If something is more dense than water, like this fairy, it's made out of ceramic, she's pretty dense. Whatever they use, the concrete or whatever to make her, she's going to sink in the water because she is much more dense than the water. So we're going to do, when is it used? It's used by lots of different things. People, when they make beer and wine, if you've ever been pregnant and every time you go to see the doctor, you pee in a cup, they're checking the density of your urine because it tells them how much protein is leaking into your urine. And if you get too much protein in there, then you get put on bed rest. But all women should be resting and enjoying life when they're pregnant. I think we should all just be doing that. So it's used a lot. It's used by chemists. It's used when they make concrete. If they want different things, it's used with plastics because they want plastics for different reasons. And so like the least dense, the lightest thing is called aerogel, AERO gel. And they can actually show a piece of it and they put it on a flour and it doesn't squish the flour. Like my piece of paper would squish the flour even though it would float on water until it got soggy with the water and then it would sink. So, yeah. All right. Like one of the other stories I tell, Tinkerbell will tell, is the original Indiana Jones. Very first scene, he goes into the ancient tomb and he goes past all the obstacles, right? And he gets there and there's the golden relic and he has a bag with him. It's a bag of sand and he sits there and he estimates the size of the relic and he takes out some sand and then he deftly switches it because he's Indiana Jones. Then he has it and he's so excited and then, right, that ball comes down on him because if he gets the mass right of the gold in the sand, he'll have the volume wrong. The only thing, if he gets the volume right, estimating it, he'll have the mass off because mass, the density of sand and the density of gold are actually different. The only thing he could have replaced it with was a gold relic that was the same, made out of exactly the same thing. So if it was truly pure gold, and so that's why, but of course he escapes, he's Indiana Jones. All right, we're gonna do the example and we're gonna do fairy dust. And so the disclaimer Tinkerbell has to make here is that the fairy dust is only for this page, this problem. We're not gonna use this problem again. So every problem, I will either give you information to figure out the density or I will give you the density in the problem. So you're either going to be solving for the density. We're going to use a number here and then we use it for a couple problems on the page. All right, so the density of fairy dust, it says you have 5.678 grams and it would occupy a volume of 6.54 milliliters. And You would get your handy dandy calculator out, you'd punch it in, you would get a number, and then you'd respect sig figs, because we learned about those from Tinkerbell. So my mass has 4 sig figs, because we were in lab and our scale allows us to do that. There's the decimal, make sure you can see the decimal, make sure you can see mine. Our volume has only 3 sig figs. So our answer has 3. 0.868. We have to round, and then grams per milliliter. And that's our answer. Reminder, the 0 before the place value. Get in the habit of showing it. Make sure I can see the decimal. Do not put this one in scientific notation, because it would be much more effort to say 8.68 times 10 to the negative 1. Again, scientific notations for really big and really little numbers. Doesn't look like we get to use it on this page. All right. So the question asks, if you had 101 grams of fairy dust, what would be the volume? Well, there's different ways we could solve it. We could do it algebraically, where we plug, let's go through the mess of it. Maybe not. We would say density equals mass per volume. We would say, okay, we're solving for volume. We rearrange and we say volume equals mass over density. And you can go, oh, I love algebra. You're going, oh, wow, how'd she do that? Wait, do it again. There is a way that I'm going to do all of these. And this is why I taught you that railroad track, the factor label conversions. All right. I would take my 101 grams of fairy dust. And what I would do, you can do it, it's the same thing as what I just did algebraically, is, I'm going to use this. I make my units cancel. So the gram comes down here and the milliliter goes on top. So unit conversions are amazing. Once you embrace them, it's a tool. It doesn't mean you have to always use them, but we're going to use it on this page because it's something we're learning and we're building towards getting to use it, because with the periodic table, it rocks. All right. With density, the number always goes with the mass. 0.868 grams to 1 milliliter. So per means per 1. So it's always 1 of the volume. So basically, remember what I said up here, sorry, density equals mass over volume. So volume is going to equal the mass divided by the density, and that's what I'm doing. When I flip it upside down, I'm just dividing by the mass divided by density. Or you can just be like, okay, my units cancel. I'm at volume. We've got it. 3 sig figs, because everything had 3, and 3 is a wonderful number of sig figs. 116 milliliters. Answer makes sense. It should take up more space than the size of it. I mean, the mass fits into more space. There's like wiggle room because the density is less than 1. That's how Tinkerbell thinks. It's fairy dust. It's gonna float on water. It actually asks that if you put it on water, it's gonna float because it's less dense than the water. Specific gravity. Specific gravity is the density of substance X, just say X, over the density of water. Now, by the way, I'm going to use a D here for density. Not sure why. That's what Tinkerbell's using. There is actually a symbol that is designated for density, and it is, I know it looks like a P. It's a rho. So write it down here. The lighting in here is funky on me. So there's our rho. It's a sign. And most students are like, what is that sign? If you're going into engineering or science, you'll probably use that. A high majority of you will not be going into that, so you can absolutely just put a D. And if you ran into a question like on a homework and I used the rho, because sometimes that happens, I don't even realize I used it because in my brain it's already there, it's density. You could always ask me. I'm there for you. Or you'll notice the units are mass per volume, and you'll say, oh, that's the density. So let's do it for fairy dust. 0.868 grams per milliliter, always showing your units, really good habit, over 1 gram per milliliter. Well, any number divided by 1 is that number. And something else really cool happens, which is my units cancel. So the units cancel. What happens is my specific gravity is just a number. I know, I said chemists always have units. Specific gravity is a number compared to the number 1. If you have a specific gravity less than 1, it tells you it's floating on water. If it's greater than 1, it's sinking in water. It's comparing to 1. You could do, so again, this is like people who are making alcohol, wine or beer, they have a little floating bob thing. We actually do this in lab. It's actually a really quick way of checking density. And so you get a number, this is a number, and then you just put the units on of, in chemistry, grams per milliliter. The density unit that we like to work with in chemistry is grams per milliliter. We work with small units. A gram is like a grain of salt. It's more than a grain. It's probably like a cube of salt. And then a milliliter, there's 20 drops of water in a milliliter. So a milliliter is 20 drops of water. So you can imagine that. Yeah. A tablespoon is 15 milliliters. Kind of some cool stuff. We'll talk about this at some point because I use an analogy with it. You don't need to know those numbers. I'll tell you when you need to. What I wanted to mention was we tend to use grams per milliliter. A milliliter is the same as a cubic centimeter. So you may see grams per cubic centimeter. This tends to be with a liquid, and this tends to be with a solid. My science and engineering majors, my 200 level class, so Chem 151 Law, you're getting ready for that. We will use grams per cubic centimeter sometimes. Those who are in Chem 104, we may see it in one problem. And again, you have me in office hours, you can go over it with me. I think we have one on this page. We do at the bottom of this page that we'll be using. All right. Let's do, I was going to show you other units. And you could have kilograms per liter. Sure, it's a mass per volume. How about kilograms per cubic meter? That's actually what people in physics use a lot, especially astronomy, because they're dealing with really massive things like Jupiter. You would never give Jupiter's density. They wouldn't say in grams per milliliter. They're going to talk in big terms. And so it's a mass per volume. This is really bizarre because it's US. Pounds per quart technically is density. Technically is not, but for our purposes, sure, it's a mass per volume. The reason I said technically not, because a lot of people will say pounds is a force and not a mass, and that is true when you're in physics and traveling to other planets. In our class this term, today I'm not planning to do any interstellar travel with you, but you never know what will happen in your dreams, right? What would not be, that is not density, because that is volume per mass. In the problem we just did, which was factor label, it was a tool to solve. And so you can flip it upside down to use it to solve, but if I ever ask you what is the density, it is always mass per volume. All right, read my stories. It's a question they ask later in the story. So let's do some problem solving. Because you are all masters of problem solving at this point, hopefully. All right, so I am on question E. Let's go down here. And E says, hey, let's find it in pounds per gallon. So our starting point for this page is the fairy dust, 0.868 grams per milliliter. Now remember, when we're doing factor label, you don't want to use a slash, a diagonal slash. I really love these railroad tracks that a student taught me eons ago. And I like to always write down where I'm going. And again, write it as a fraction. So they're called factors because they're fractions. You can use parentheses again if you like them. I'm not attached. I just have a preference. When you use the factor label boxes, the railroad track, you can only have one unit in each box. It's a great teaching tool for me to remind you of that. The other thing I learned over the years, I write it like this, and I'm okay with no number there, the void, because really we're 99.99999999999% nothing. But what I learned is most students don't haven't yet embraced the nothingness. Magical things happen when you do. So it is always 1. So you put a 1 there. So if you had like miles per hour, it is per 1 hour, or grams per milliliter. It's that many grams per 1 milliliter. This number at the top, the grams, will be different depending on what substance we're using. All right. Oh, we're going to pounds per gallon. So we've talked about conversion factors. Little misnomer, taught you about that. So let's write them out here. We have 454 grams is 1 pound. And I use this conversion. Again, students, I like to just keep everything simple. And back in the good old days, I recommend you just make a simple note card with those conversions on. So hopefully you grabbed your note card out, and we're going to do liters to quarts. And this will give us practice doing extra steps. All right. So 0.946 liters is 1 quart. You can go with the 3 sig fig rule. If you want to know them to 4, you can do them with 4. This would have a 3. All right. So I'm going to pull this unit down, and I'm going to change it to pounds. Again, this piece holds true by itself. That's why you have study sets and worksheets and stuff, so you get practice, so you've got this. So when we get to the periodic table, when we get into gnome language, because the original periodic table was them. All right, the US unit gets the 1 with my method, and grams is 454, and we cross out the grams, or if you use 453.6, that's fine. All right, I like to circle. I got 1 of my units. I don't want to cross that one out. Now I'm going to pull the milliliters up here, and some of you will say, oh, Dr. Sherp, I just Googled how many milliliters are in a gallon, and you get this crazy number, and that's great. And then you don't understand what to do with the number. I'm going to go through using this. I'm going to change my milliliters to liters. And you can either do, there's 1,000 milliliters in a liter, or if you're like going, well, let's do it the way you were showing with the chart, you would say 1 milliliter is 10 to negative 3 liters. So you always define the metric unit. The prefix gets the 1, and then 10 to negative 3, or 0.001. Again, if you do 1,000, you would say 1,000 milliliters on top. I like to cross out units when you're first learning. We have liters. So this is the unit I'm working with. I'm going to pull the liters up, change my liters to quarts. Did I really say yes? So US gets the 1.946. It's really silly always saying the US gets the 1, number 1. But it's how Tinkerbell's mind can look so charming up here. All right, cross out my units because I'm going bottom to top here. Bottom to top. Quarts to gallons. All right. You guys get to have a cheat sheet. But in the old days, you all know you'd have to have 4 quarts of ice cream to eat a whole gallon of ice cream, or 4 quarts of milk. We'll give you a gallon of milk. And we would punch it in. 3 sig figs. So, numbers that were measurements, density, and US metric conversions. If you're going with 3, they have 3. Metric is exact. US measurements are exact, or imperial is actually what they are. So we have 3 sig figs, or you can just always do 3 and say, I really don't like sig figs, I'm just doing the 3 thing. And look, we got it right. Units. When you give your final answer, you can absolutely use the slash because it's now an answer, but when you're doing the work, there's no slashes in the work. So 7.23. Can rewind, do it again. If you didn't quite get it, you can move on. You can also start it and say, yeah, I didn't get it. I want to go over it with you. And remember, don't use that language and say, I don't understand anything. Say, Dr. Sherpa, I would like to go over the specific question with you. And I will find the question. I'll have my notes there. And we'll walk through it one-on-one. All right, that's the magic. Don't be shy. In fact, you have to come to office hours. My wings are fading, aren't they? All right, that was E. Let's do F. All right. All right, we're traipsing through the woods, which is fairies would flutter, and we have 1.2345 kilograms of fairy dust. Oh my gosh, imagine what you could do with that. So much magic you could do. You could just make so much magic. All right, what are we solving for? We want to know how many quarts that is. So let's write down where we're going. Now, this is a mass, kilograms. This is a volume. The bridge to get you from mass to volume is the density of whatever it is that you're talking about. And so for this page, it's this number. Every other problem you do, it's not going to be this number, so it'll be whatever number I give you. So I'm going to start with the kilograms, and I need to get it to grams because that's what I gave you the density in. And we're not going to break it into multiple steps. We're going to do it in one nice, beautiful factor label. The unit comes down kilograms, and I go to grams. Kilo gets the 1, and the 1,000, you can either write it as 1,000, or you can say, okay, I'm doing the 10 to the 3. I've had students, again, I've told you that did not like my scientific notation. You can use 1,000 or 10 to 3. Either way is great. We cross out the kilo. We're at grams. You cannot change grams to quarts. You cannot change grams to ounces and make that a fluid ounce. That's only true for water, and we're not dealing with water. This is where my density comes in. 0.0868 grams to 1 milliliter. I have to flip it over for the unit to cancel. Again, density is always mass per volume. The volume gets the 1. But now I can change my milliliters to quarts. I'm not going to Google and try and figure it out. That's going to take you a lot of time. If you do these problems that I give you, these practice, and do them again, and only use the conversions that I give you on the page, you'll actually do it faster. Because you'll go, okay, I know I need to get to liters. I'm going to change my milliliters to liters, and then my liters get me to quarts. Liters to quarts is my bridge between US and metric. Milliliters, and you can do 1,000 milliliters to a liter, or milli is 1,000th of a liter. So again, 10 to the negative 3. That's the magic of what metric really is using a negative exponent. Milli is a small unit. It's a very small amount. It's drops. Liters, kiloliters, kilograms, they're big. It's like you and me, we're kilogram size. All right, US gets the 1, so the 0.946 goes with the liter. Quarts and liters are really close. A liter is a little bit larger than a quart. And again, you can do 0.9463 if you're doing the 4 sig figs. Let's talk about sig figs. The original number I gave you has 5. The conversions between US and metric limit us, and density does have a limited number of sig figs. So if you use my conversions that I'm giving you, which have 3 sig figs, you're not going to have more than 3 sig figs. Unless it's using conversions, different conversions. So there could be a time. All right, I got the answer to 3 sig figs, 1.50 quarts. This is time when I pause and ask, are there any questions? And you can rewind Tinkerbell, 30 seconds, a minute. I'm going to do one more problem. And we can go down here. Whoop. Look at all this work on the board. All right, we're still dealing with fairy dust. Repeating myself. There's fairy. She's getting covered with fairy dust. Which is why I love chalk. Always covered with fairy dust. Okay, you have a locket. I have a locket. My son, Joey, gave me a locket. It was beautiful. It is beautiful. All right, let's go down here. 3.1416 cubic inches. And it wants to know how many grams. I'm going to show you, this is a cubic problem. You may see one question on like a, I don't know, a worksheet or something that deals with the cube, and I'm going to show you two different ways you can deal with it. So what we know, US gets the 1, 2.54 centimeters is an inch. Now again, somebody declared they're exactly the same. They're not, but somebody declared it who was able to, and everybody believes them. Imagine that. What power can do for you. So we have to change inches to centimeters, but we have to do it 3 times. Because once we get to cubic centimeters, talked about a little bit earlier, if we did not write this down the other day on your handy dandy little like conversion page, that's really simple. Don't get, the tutors are amazing. Don't use their crazy big page. Trust Tinkerbell on this one. Trust Tinkerbell. You could trust your teacher too. This is handy to know. So I'm going to change my cubic inches to cubic centimeters. Again, don't copy what I'm doing. Decide which of the 2 ways you want, and then you can pause Tinkerbell. So you can change an inch to a centimeter, and then you either have to do this step 3 times, and then, this is a handy step, you can say a cubic centimeter is a milliliter. There's a reason I did that. But these 3 inches down here, this is a 1. You can leave the 1s off. That will cross that cubic centimeter. And then these 3 centimeters will cross that one out. And you're at milliliters. And I went to milliliters because the fairy dust density. 0.868 grams to 1 milliliter, I think is what we were doing earlier. And we punch it in and you get 44.7. All right, I'm going to show you a different way. Oh, can you see that? Can't see my unit. Show units. That is Tinkerbell's message to you. Units are crucial. All right, so some of you are like, well, what about doing it? There is a shorter way. It really depends how your brain sees 3 dimensions. It doesn't matter to me which way you show it. You don't get unlimited time on exams. You kind of get unlimited time on worksheets and stuff, but not really, because there's a due date. And if you wait till the last minute to do it, then you really ran out of time, right? Don't wait till the last minute. You can also show this step 1 time, and then you cube it. Now, this is the way that you're taught to cube it, right? And then we bring in our last step. Oh, you can bring in this step also. Sorry, just forgot. You can show it that way. The problem is this cube is here, and when you go to punch it in your calculator, you forget to cube that step. This is my recommendation. You can go that way and say, I'm just going to show it 3 times. Fast forward 30 seconds, or you can be like, okay, show me your step. What I do is I cube everything. You don't have to cube the 1, but you can because it's 1 cubed. But I cube the unit and the number. Because then when I punch it in my calculator, you're going to punch in 3.1416 times 2.54. Up there, times 2.54 times 2.54. You can ignore ones, times 0.868. Here you would just use the chevron key to the third. And then you would say times the 0.868. Now, this is another little shortcut for those of you who like it. If your brain recognizes which by 221, by the end of it, it will. And for many of you, it already may have, some of you, milliliter and cubic centimeter are the same thing. So the unit cancels. It'd be really hard for Tinkerbell to think of another unit that would cancel like that. But a milliliter and cubic centimeter does. All right. Until next time, I lost my wand again. Ta-ta.